So my name's Ashoat. I'm the founder of Calm, which is a startup building like a Web3 Discord powered by Keyservers, right? So in this talk, I'm not going to try to shill you too hard. I'm trying to do kind of a shortened technical talk, and this is kind of the talk that I pitch this startup like 5 times a day, and I always wish I could give this talk. This is sort of like the technical talk, and I'm going to really try to zoom in onto the question of like, why are Keyservers necessary, right? And the fundamental premise of our startup is today Web3 is blocked on Keyservers. And what I mean by that is, we have kind of a world where you sort of have to pick between 2 things. One is you can have like a centralized Web2 product that has a lot of product functionality, it's very powerful, can do a lot of stuff. And on the other side, you have kind of more decentralized applications, things that have end-to-end encryption, things that support sovereignty, that on the other hand, don't have the exact same product functionality. And you look at kind of the world of Web3. You guys are all probably on Discord or all on Telegram. Unfortunately, centralized applications. So the question here is like, how do we, as a community, move out of that space? How do we get to a world where Web3 communities are actually using products with Web3 values? Let me see. And this is a fun talk to give because most of the time when I give this talk, one thing I've noticed is people that don't really know kind of the space too deeply will kind of buy into what I'm saying really quickly, right? But people that really know like what it takes to build a decentralized kind of Discord or a decentralized Telegram start to push back. Because the reality is there's actually been a lot of projects that have tried to do this, and there's a lot of really cool cryptographic techniques to kind of enable this stuff. And so in this talk, we're going to zoom in. This is really fundamentally kind of a tech talk. And one thing I'm just going to say, we're not going to be talking about the UX challenges of getting people to set up a key server. I'm optimistic about it. Obviously, it's something that's not something that completely will be easy, but that's outside the scope of this talk. All right, first I'm going to start with a quick definition of what a key server is. So if any of you here have worked in like enterprise key management, you may have heard this term before. We aren't using it in the same way, okay? So we're hijacking the term. So a key server in our system, fundamentally, it's a personal private application server, right? So in our vision of the world, each of you has a key server, right? Your key server owns your private keys and your personal data, and your key server has to always be online, right? It's got to be something that's truly a server, can respond to requests at any time. And last piece here, kind of how we envision key servers going, we want to kind of provide an alternative to the application development model that exists today, where you have a centralized cloud server that provides a backend. In our model, we replace that with a federated network of user-owned key servers. Now, to really explain why key servers are necessary, I'm going to spend the rest of the talk talking about previous attempts to build private messengers without key servers. And so, to get started here, can I get a show of hands? I want to see who here knows who Moxie Marlinspike is. All right, not too bad, not too bad. Who here has read Moxie Marlinspike's Web3 critique? Anybody? All right, we got some folks. And how I look at this, I saw a tweet like maybe a couple months ago, Web3 needs better critics, and I really truly believe this. And Moxie's a great critic. And I kind of have a hot take. I'll throw this out there. I actually think Signal was the first Web3 project, right? And I look at this basically because, fundamentally, to implement end-to-end encryption, Signal has to decentralize the database. Before Signal, there was a centralized database in the cloud for every messaging app. With Signal, actually, your phone owns your actual private keys and your private data, right? And Moxie's been working kind of on this problem for a long time. And, we all know kind of Signal has some limitations. There's a reason a lot of us use Telegram instead. And Moxie's been, butting his head at these kind of limitations for 8 years, right? And so it should come as no surprise that the very first thing he mentions in his critique, right at the start, people don't want to run their own servers and never will, right? And if you kind of, the two most salient quotes from this article to me, first one is Web3 should give us the richness of Web2, but decentralized. I believe in that deeply, right? That is what I think the goal of Web3 should be, right? And the second one, people will never run their own servers. Moxie is a doomer, right? So Moxie, I can't blame him, right? So far, to date, people have not been running their own servers, and so it's kind of a good mainstream bet to say that, it won't actually happen, right? I disagree, but that's outside the scope of the talk. Taking another kind of perspective on the other side of this. So Pavel Durov, he's the founder of Telegram, right? And he's very, very sensitive about the fact that Telegram is not end-to-end encrypted, right? And it's funny because Telegram launched with end-to-end encryption. Believe it or not, when they first launched, they had support for a bespoke end-to-end encryption protocol called MT-Proto. And over time, they have iteratively just de-emphasized that. And today, you got to go through like a menu tree to even start an encrypted chat in Telegram, right? And if you ask him, what's the difference? Fundamentally, he talks about this thing seamless sync. He also sometimes calls it cloud sync, right? And what he's really getting at, right, is the user experience around backups. Oh, enter. The quote here from the article he wrote, "We didn't want to deprive our users of functionality that they enjoyed in other apps and doom Telegram to join the ranks of niche apps," right? Pavel, too, he's a doomer. He, too, doesn't believe that there's any way to solve this problem, right? But similar to Moxie, he gets that it's a very serious problem. All right, so, you can sort of imagine now a spectrum, right? A spectrum going from, Telegram on one end, which focuses on product functionality, that's their priority, and trades off sovereignty. And on the other hand, you can look at Signal to say, Signal's a pretty sovereign platform. You have privacy, you own your own data, but obviously the product functionality is pretty limited, right? Telegram can do a lot of stuff Signal can't, right? I mean, you got 1,000-person channels in Telegram. You've got a web client. You can scroll up to see message history when you get added to a chat, right? And when I'm usually giving a pitch, this is usually where I stop, because I don't want to get too technical. But the rest of this talk, we are going to dive deep, right? And we're going to talk about other attempts to actually try to bridge this gap, to try to build a private messenger that guarantees sovereignty with the same sort of functionality that Telegram has. So, enter. There it is. So Keybase. Who here has heard about Keybase before? Raise your hand. Okay. So we have some folks. Not everyone. Keybase is, you could think of it as like a decentralized Slack. That's not where they started, but that's kind of where they are today. And they take a couple really opinionated different takes on end-to-end encryption, right? So the first thing to know about Keybase is the only end-to-end encrypted application that I know of that doesn't use double ratchet or something very similar to double ratchet. Apple doesn't really tell us what they do, but they're probably doing double ratchet. So Keybase does something very different. Keybase takes a single symmetric key and uses that to encrypt all of the data in the channel, right? So you lose something called forward secrecy, which is a cryptographic principle, but there are trade-offs here. So Keybase relaxes some of those cryptographic guarantees. Concretely, is something called forward secrecy, which is this principle that if someone steals the key, they aren't able to actually read the future messages, right? So just as a quick comparison, again, it's a tech talk, a lot of words here. I'll try to break it down. In double ratchet, every single message has its own key, right? And that's a crucial thing to understand, right? Before you can decrypt message n+1, you first have to decrypt message n, right? And so on top of that, if you're in a group chat, if you want to send a message to 10 people, what you have to do in an end-to-end encrypted application that uses double ratchet is you actually encrypt that 10 separate times, send that to 10 separate people, right? And so you can imagine now the scalability challenges inherent here, right? As the group continues to grow, every message has to be downloaded to every single individual client. And on top of that, as the number of members grows, each individual message has to be re-encrypted that many times. So it's an O of n squared problem. And this is why, looking at products like Discord and Telegram that are meant to kind of scale to larger communities, no one's ever actually successfully built sort of, a private equivalent of that outside of Keybase. And Keybase kind of made this trade-off. On Keybase, I mentioned the whole channel has one shared key. The ciphertext of each message is backed up on Keybase's servers, and that enables clients to be thin clients again, right? Whereas in Signal, your client owns your data. In Signal, your client has to handle like all of the work of like search happens on your client. Like storing all the data happens on your client. In Keybase, you don't really need to worry about that. Now, the thing is, though, despite Keybase's cryptographic trade-offs, it still can't reach feature parity with Telegram. And this is the app that was willing to put, the most on the line, trade off the most cryptographic principles, right? But the best example here to talk about is search. If you go on Keybase and you go to the search bar and you type in a query and you hit enter, here's what Keybase does. Keybase proceeds to download each message one by one to your client, decrypts it on your client, searches it on your client. If it finds it, it shows it to you. And then you have the choice to say next, or you can say I'm done, right? And if you say next, then it spins again. It spins and spins and spins. It fills your hard drive up with messages. It might take an hour. Hopefully, eventually, you find what you're searching for. Obviously, as a user, this is a broken product experience, And how I look at this is there's a reason our Web3 communities are on Telegram and Discord and not on Keybase, right? Now, the next slide is the most technical of the slides, so going to do my best here. So I want to talk about searchable encryption. there's been a technique for a while. It was initially pioneered, the year 2000 was the first research paper I could find about it. Really, the best research paper, though, came out in 2006. So that's really when it became kind of a mainstream concept. And searchable encryption, to understand it, I'm going to first have to explain a little bit about search. So there's a core part of a search engine called the tokenizer, right? And the tokenizer, what it does is it takes a bunch of text and breaks it down into smaller individual tokens. These are not crypto tokens. These are just like short strings, right? And so the way the place that this tokenizer is used is actually in two spots. It's used first when indexing content. So when looking at, let's say where it's Google, so the content would be a web page. You first tokenize the content of the web page, and then when you're executing a search query, you tokenize the search query, right? And the whole point, what a search engine fundamentally does is it's matching those tokens. It's matching tokens from your search query to tokens from documents, right? Now, tokenization, obviously a very critical part of search. And searchable encryption, the way it works is it actually inserts itself on into the tokenization layer. So what's going on in searchable encryption is after tokenization, you encrypt each token in a way that the server isn't able to figure out, like, what is this token really? And as long as you encrypt the tokens during indexing in the exact same way that you encrypt the tokens during search, the server can match up these cryptographic encrypted tokens and not actually know what's going on, right? So you might ask, why didn't Keybase do this? Why don't other folks do this in general? And the reason fundamentally is any change to the tokenization algorithm now requires re-indexing all of your content, right? And this kind of comes back to the same problem we started from. Like Signal has all the data on your phone. And if it was possible to treat your phone like a server, Signal wouldn't have any limitations it does. But Apple, in particular Apple, less so Google, Apple really is very restrictive and does not let you just issue background requests. And if it's the case that a change to a tokenization algorithm requires re-indexing all that content, that can only be done on the phone. And so we're back to square one. We're back to a world where the device that owns your private keys, unless it can function as a server, is not actually able to handle search for you. All right, so talked about Keybase. Next one I want to talk about is matrix.org here. And I think I have not too much time left, so I'll try to go fast. Enter. There's matrix.org. All right, so matrix.org actually does implement double ratchet, unlike Keybase, like we talked about. But matrix.org does a lot of stuff other end-to-end encrypted apps do not do. So it's got the full backup, and it also has a web client. And you might ask, how does it do it? And the answer is basically brute force. So if any of you here use matrix.org for end-to-end encryption, you know what I'm talking about. If you log into Element, which is the mainline web client for matrix.org, and you haven't logged in before, your browser is going to freeze. There's like a GitHub issue about this. Your Chrome browser freezes for 10 minutes while you download literally every message, all the backup to your web browser, decrypt it in your web browser, and then you actually are storing it in your web browser. And web browsers not really that great at being full clients here, right? Oops. So, 5 minutes. Oh, that's not too bad. So matrix.org and Keybase both solve the backup problem, but do it very differently, right? And so matrix.org just has a big blob of your data, right? And that gives you a bit more privacy because the metadata is kind of hidden. Keybase instead breaks the backup down to kind of individual pieces, right? Okay, so now I'm gonna end the talk with a bit of shilling here. So Keyservers solve everything, right? All the stuff we've been talking about, the challenges that Keybase faces, the challenges that the matrix.org face, stem from the fact that they do not have a server that has access to plain text data. The solution with Keyservers is we can have a server with access to plain text data, but it can be owned by the users. Instead of that data being owned by a cell phone, that data can actually be owned by your key server, right? And all the stuff we talked about, you can have a thin web client that just talks to your key server, so web works great. You can have the full protection of double ratchet, right? Because you can just query your key server whenever you need to. You can have backup be done in the background by your server, and obviously you can scale to larger communities because I mentioned earlier Signal in the group chat, you need to encrypt something n times. If you have a key server hosting a community, you can just send that message to that key server once, and it can handle the fan out for you, right? So personal private servers enable the best of both worlds. They make it possible to have the security and privacy of Signal while having the product functionality of Telegram. The last thing I'll say, I believe key servers are inevitable. I believe they are going to happen. Because as time goes on, the amount of information we have about people grows at an exponential rate. And today we worry about privacy for messaging. But tomorrow we're going to have, privacy for glasses that record everything you see and everything you hear, privacy for your personal AI that knows literally your whole life, right? And, key servers really are the only way to get this future tech while preserving privacy. And privacy matters much more when it's your whole life being tracked. So yeah, that's a talk. Any questions?